Welcome to Simply H2 Math video series specially made for JC students. I'm Mr. Song from Learning Simplicity. In this first series, we shall discuss about sequences. A sequence is an ordered set of elements, usually numbers. It can display some pattern so that it's possible for us to guess the next number in the sequence. Sequences in general can be random. It can be displayed as the following: U1, U2, U3, all the way to UN and UN plus 1. This is a set of sequences. Examples of sequences can be 1, 2, 3, 4, 5, and 6. It can also come in the form of to the power 0, to the power 1, to the power 2, to the power 3, to the power 4, as well as to the power 5. Let's look at the representation of a sequence. A sequence can either be represented in the form of a general formula or as a recurrence relation. For the general formula form, it is a more convenient form as you are able to get the term immediately by plugging in a certain value of n. So for a general formula, we can represent them in terms of n. Examples of general formula form will be as such. The first example, we have un equals to n plus 1 over 2. Also, we can have un equals to n plus 1 over n plus 2. The third representation can be in the form of un equals to 2 times half to the power of n minus 1. The last example, un equals to 1 plus 5 times n minus 1. Did you notice that the last two sequences described above are some special progressions? Next in line, we talk about the recurrence formula for the general term. A recurrence relation expresses the relation between terms in a sequence. To define a sequence in the recurrence relationship completely, initial conditions are required. In short, a recurrence relation depends on the previous term. Examples of recurrence relations can be as such. Let un equals to un minus 1 plus 2 and letting u1 equals to 1 as an initial condition. Other examples will be un plus 1 equals to un plus un minus 1 or un plus 1 equals to square root of un plus 2 and so on. Next we come to convergent sequence. This is the last section of this video series. Essentially, a convergent sequence means that the terms of the sequence tend to a certain real number as the term number increases. I would say, as n tends to infinity, un will tend to L. Otherwise, the sequence is known to be a divergent one. In short, terms tend to a certain value as we reach a large number of terms. I would say un tends to a constant value L as n tends to infinity. To find the convergent limit of recurrence relation, let's explore the following example. Suppose un plus 1 equals to square root of un plus 2. As n tends to infinity, un tends to a certain value L. un plus 1 also tends to L. Therefore, L is equal to square root L plus 2. L squared is equal to L plus 2. L squared minus L minus 2 equals to 0. Using the quadratic formula, L equals to 1 plus minus square root minus 1 squared minus 4 times 1 times minus 2 divided by 2 equals to 2 or minus 1. Minus 1 is rejected as the sequence consists of positive terms. To find convergence of a general formula, we can use number 1, finding limits. By finding limits, we are dividing throughout by the highest degree of n. Examples will be, as n tends to infinity, un equals to n plus 1 over n plus 2 equals to 1 plus 1 over n over 1 plus 2 over n. tends to 1 plus 0 over 1 plus 0, which is equal to 1. Next, number 2, we can also sketch a graph using VC to find the convergent limit of a general formula. Supposedly let y equals to x plus 1 over x plus 2 equals to 1 minus 1 over x plus 2 using the technique of long division. By drawing the graph using VC, we can find that the horizontal asymptote is equal to y equals to 1. The vertical asymptote will be x equals to minus 2. The graph is that of a hyperbola shape. Look at the value of y as x tends to infinity. We realize that as x tends to infinity, y will tend to 1. This also means that the convergent limit of this general formula is essentially equal to 1. That's all for the lesson on sequences. Hope you have enjoyed and benefited from the lesson. Watch out for the upcoming Simply H2 Math video series.